Hi everyone, this is Mrs. Turigno, and this is the second page of the Chapter 7 test review. This video will cover questions 7 through 12. Okay, let's start with number 7. Okay, this is asking me to simplify this expression that includes quite a few powers, but I don't want you to miss the fact that there's a square up here, and I also want you to notice that square only applies to this first set of parentheses. So before I do anything over here, I need to get everything in here squared. Remember that 8 works completely differently from the powers. Okay, so the 8 is a number, a to the 7th and b are both powers. They're both exponential expressions. So I'm going to take that 8 and raise it to the power of 2, which gives me 64. But when I start to work with this power, I'm going to use the rule that says that when you raise a power to a power, you multiply those exponents. So this will become a to the 14th. So just don't make a mistake and accidentally do 8 times 2. Remember, you want to do 8 to the power of 2. But then here, because these are both exponents, you'll multiply. And this b, it doesn't have anything on it right now, so when I square it, it'll just become b squared. And then I still have to take that and multiply it by this other set of parentheses, 5a to the 6th, b to the 8th. Okay. Now, when I'm combining things within these two parentheses, remember this is multiplication here. So when I'm dealing with the 64 and the 5, let's remember that those are just regular numbers. So I'm just going to multiply 64 times 5. And when you do that, you should come out with 320. Now, when I go to multiply two powers together, remember your rule is to add the exponents. So when I am multiplying a to the 14th by a to the 6th, I'm really doing 14 plus 6 and getting 20. That'll be a to the 20th. And then same thing here. I'm just going to add 2 plus 8 and end up with b to the 10th. And so your final answer there, as simplified as it gets, is 320, a to the 20th power, b to the 10th power. Question 8 is also asking us to simplify, and this one starts with some negative exponents in it, but I wouldn't let that throw you off too much. This is a division problem, so I'm going to start by splitting up my pieces here. I have numbers here, I have a's here, and I have b's here. I'm sorry if you can't read those from there. And again, because this is a division problem, I am just dividing that 16 and that 2. No fancy rules here to follow. I'm just doing what the problem says. So 16 divided by 2 is 8. Now, those negative exponents, some of you may be looking at that and saying, oh, I know what that means. I know that those have to switch sides, which is true. But also remember that I told you not to worry about those negatives until you get to the end, because sometimes those negatives cancel each other out. Case in point, right here. When you're dividing with powers, you want to subtract the exponents. So I'm going to do negative 4 minus negative 6. And you may be better off writing that out for yourself. You're less likely to make mistakes that way. Now, negative 4 minus negative 6 is really the same thing as negative 4 plus 6, which is positive 2. That means I'm coming out with just an a squared out of that whole mess. So that's why I'm saying not to worry about the negatives right away, because sometimes they don't end up mattering. So let's check this. This is 3 minus negative 2. And remember, 3 minus negative 2 is really the same thing as 3 plus 2, which is 5. So here I'll end up with b to the 5th. And that'll be my final answer, 8a squared b to the 5th. Okay, question 9. I know question 9 looks scary because it's got some scientific notation in it, but really it's just following the same rules of exponents we've been doing for the whole chapter. And I also know that many of you are intimidated by word problems, but here's what I want you to pick out of this problem. It gives us a total energy consumption, and that is 6.99 times 10 to the 15th BTU. That BTU is just a unit that we measure energy in. Okay, so don't let that mess you up either. This is really your focus. 6.99 times 10 to the 15th is the total energy consumption. And then the total population, which means the total number of people, is 3.04 times 10 to the 7th. The question is asking me to find the average energy consumption per person. So think about this. We've got total energy and total number of people, and I want to know how I can find out how much each individual person used. If you need to, think of it as a simpler problem. If I had $50 total and I had 10 people in class that I was going to split it up between, how would I figure out how much each person gets? Hopefully you can come up with division. We want to take the total energy and divide it by the total population. That will look like this. 6.99 times 10 to the 15th. That's that total energy we were talking about. And divide it by the population. 3.04 times 10 to the 7th. And what I'm going to do this problem is I'm just going to split this right down the middle. So here I'm dividing. I'm just going to do 6.99 divided by 3.04, and I end up with 2.30. I'm rounding to 2 decimal places there, by the way. You actually come up with 2.299, and then it continues from there. So we're just going to round to 2.30 times, now here, these are both powers of 10, so I can follow my rules for exponents. And my rules say that when I'm dividing, I can subtract those exponents. 15 minus 7 is 8, so this will become 10 to the 8th power. And that's it. That means that each person used about 2.3 times 10 to the 8th BTU of energy in 1993. Okay, number 10. There's a key word in number 10 that makes this problem a whole lot easier than it looks at first. It says estimate 9.75 to the 2/3. And also notice it gives you a place to round to the nearest hundredth. That means your answer is going to come out as a decimal. And when it says estimate, you can just type that straight into your calculator. So, in case you weren't sure how to type this in, let's make sure you can see that. I'm just going to type in 975 to the power, and on this calculator I do need to make sure that 2/3 is in parentheses. Okay, hit enter, and it said to the nearest hundredth. That's 2 decimal places, so since the number after that is a 6, that will round that up to a 3, and my final answer here will be 98.33. And that's it. Anytime it says estimate, you're just typing it into your calculator and giving a decimal approximation. Okay, number 11, another word problem that, again, many of you are going to be intimidated just by the fact that it's a word problem. But it's a formula, and formula word problems are really never as bad as they look. It gives you this formula, D equals 1.82 R to the 2/3. And I think the easiest way to start working with a formula is to figure out what each of the letters represents, so that later on when I'm plugging numbers in, I know where they're supposed to go. So here it tells me that D is the distance from the sun, and I'm just going to label that here, that this is distance. And R is the number of Earth days, so R is number of days. Just abbreviating a little bit there. So when I get down here, it says Venus revolves around the sun once every 225 days. Right there, that's your number that you're plugging into the formula, and all you have to do is decide where it goes. Since we already labeled these, that makes it really easy. This 225 is a number of days, so I'm putting that in place of R. So all I need to calculate is 1.82 times 225 to the power of 2/3. And that can go straight into your calculator. So, and again, I want you to see how I'm typing this in here. I'm typing in 1.82 times 225 to the power of 2 divided by 3. Okay, hit enter, and I end up with 67.3 million miles because my distance is measured in millions of miles. And that's it for that one. So hopefully that's not as scary as it originally looked. Okay, number 12 wants us to solve 2x to the third minus 50 equals 200. We did quite a bit of this on the first part of your test review. But when you're solving an equation, remember that's like you're undoing everything. And the first thing you should always undo is anything that's being added or subtracted. So we have a minus 50 here. Let's get rid of that. And I can get rid of a minus 50 by adding 50 to both sides. I end up with 2x cubed equals 250. And now many students will want to get rid of that power of 3 next. Remember, you cannot get rid of your exponents until you have everything away from that variable, which means we need to get rid of this 2 next. And I can do that with division. I'm going to move over here so I have more room to write. I'll end up with x to the third equals 125. Some of you might actually know that answer off the top of your head, excuse me. But if you don't, think about how I can get rid of a power of 3. Anytime you're trying to cancel out a power, really all you're doing is raising to the power of the reciprocal. The reciprocal of 3 is 1/3. So I'm doing 125 to the power of 1/3. And it would be okay with me at this point if you're typing these into your calculator. So 125 to the power of 1/3 is just 5. And so your final answer would be 5. Okay, that's it for this next video. Coming up next will be questions 13 through, oh gosh, I don't know where it goes. 13 through 17 it looks like. All right, stay tuned.